Today, we're going to work on one of those microwave ovens. It's dead. I'm not giving any brand in specific here. It's a Panasonic, but a non-inverter Panasonic, so it's a conventional design. But this applies to all microwave ovens. Every one of them has the same circuitry, so it doesn't matter. They all are exactly the same in this respect. Let's take a look. This time I've got a microwave oven. Look at this. The person who owns this has never even taken the protective film. It says remove protective film before use. And they've never removed the protective film over the buttons. Looks that way anyway. Anyway. It's dead. We're going to pop this apart and see what's going on. This is a conventional, in other words, it's not an inverter type, it's a conventional microwave. These are generally pretty simple. Let's take the top off first and see whether we've got a blown fuse. And if so, is there a reason the fuse blew? Is it a weak fuse, or is it one of the switches that's gone bad? We'll find that out. This one uses security bit. And of course, mine is not the right size. Great. I'll have to break into this one, I guess. Pick out the bigger security bit. Will this one fit it? Yes. This one will fit. Now with all those pain in the ass security screws out, we can remove the top cover. Let's see what went wrong with it. Okay, the first thing to check on this is to check for a burnt fuse. There's also a couple of thermal cutouts that we can test. Fuse is here. The fuse sometimes will fail for no reason on these. I know some people are going to find that hard to believe, but that is the case. Fuses sometimes get weak and they fail. We'll check first of all, the cutouts. That one's good. That one's good. How about the fuse? I bet it's open. Ah, the fuse is open. Okay, why did the fuse blow? Well, it could be a weak fuse. That's a known problem on a lot of these units. The fuse just gets weak after a while and pops. This isn't even the correct fuse that's in here. The fuse that's in here should be an ABC type of fuse, which is one that's filled with sand. And that's to give it some resistance to popping like this. 20 amp fuse. 125 volts. What's it call for? Oh, this one does call for a 20 amp fuse. So it is, I guess, the correct fuse, although normally you use an ABC type fuse for microwave ovens. The older ones used to use a 15 amp and then they went to an 18 amp. I guess they've gone to 20 now to stop it from blowing, even though it's a 15 amp rated power cord. So this should never trip a 20 amp fuse. There are reasons why they can trip though. And one of them is the interlock switches. So first things we're going to check is we're going to check for a shorted interlock fuse or interlock switch. And we can do that by just measuring between the neutral line and the fuse holder. Aha! We have dead short. We have an interlock switch that's gone bad. That's why this one's bad. The short switch. Someone may have slammed the door, or the short switch itself just went bad. I've gone over how these are wired before, but we'll do it again for the noobs that haven't looked at some of my older videos. So I was going to get a piece of paper, we'll draw up how these are wired, just to get an explanation as to what's gone wrong. Because this one here has a dead short between neutral and the line side of the fuse, right? This is the line side of the cord, this is the line side of the fuse, which goes into circuitry. We have a dead switch on here. I'm only going to draw this, I'm not going to draw everything obviously, I'm going to draw just the protection circuits up to as far as the transformer goes. So if you got your main power transformer here, and you've got the primary winding, and then there's the secondary winding, and then there'll be the loop around which goes for the filaments, for the magnetron, and then this one's going to be grounded here, and this one's going to go off to the diode and so forth. But we're not worried about the secondary side of this. We're only concerned with the primary side. Your AC power comes in. So here's your your AC plug and your ground prong, right? And ground is chassis. You got your neutral and you got your line input. Your live input goes into your fuse. Okay. From here, neutral, we'll take that down and we'll take it right down to one side of the transformer. From here, you go to a switch. This is your primary switch. This is the top one. This is the top door switch. So from here, now there's also other stuff off of here, like there's another transformer here. This is for the clock. So this is your timer power supply. So we'll just leave it at that. That's always got power. From here, it goes to your primary switch. When the door is open, that switch is open. And we're drawing this in a door open state. So door is open. The output of this switch goes to another switch. There's a switch here. This is the bottom switch. And it's closed. And then from here, this goes into your relay. And the relay goes back to the timer circuit. This is, I'm getting ink all over my hands from a pen that puts too much ink on the paper. When the door is open, this is the state that it's in. Top switch is open, bottom switch is closed. Relay is obviously open. I'll draw this again with the door closed. So here you are with door closed. You've got your power input. Okay, there's your high voltage transformer and the line input and neutral. And of course, the line input goes through the fuse. And now it's going to go to the main switch. And of course, coming off of here, it's going to go to the transformer for the clock. Power supply. So, and it comes along here, and it goes down to the bottom switch, which in this case is open. And then from here, it goes to the relay. And that goes back to the timer, right? So there's your relay. Door closed. Door closed. Power goes through the fuse, through the primary switch. It ends here because the relay is open, and nothing happens here because this switch is open as well. Door closed. That's door closed. Door open. This is the way it is. The primary switch opens, and this one, by the way, is always the first to open, and this is the second to open. And when you close it, this is the first and that's the second to close. But door open, power is going into your transformer to run the timer, but it's stopping here because the switch is open. Now, what would happen is, and the reason it's wired like this is a failsafe. This is to blow this fuse if something goes wrong. So in other words, in the door the door open position, if this switch were to fail and fail to open when the door opened, this switch would close and put a dead short on, which would blow the fuse. Likewise, when the door is closed, you've got power energizing ready to go. This switch needs to be open. If this switch is not open, the switch sticks, for example, or if the door is slammed excessively or someone twists the door when they're closing it, and this switch closes before this one opens when you're opening the door, for example, or the door, switch sticks closed, you create a dead short, you blow the fuse. That's how the fuses operate on this. And there's a thermal cutouts and stuff that I didn't draw, but that's basically the protection circuit. You've got two switches, one that opens the circuit and the other one that provides a dead short to kick that fuse if something fails. And that's what's happened on this one. Let's figure out which switch it is. We can do that by opening the door, believe it or not. You see, if I open the door, now I know that the power transformer on here will provide some loading, and I did not disconnect the power going in. So if I disconnect the power going into the timer board, now I've removed any load from the transformer on here. I've got everything removed there. Did my short go away? No, it did not. My short is still there. I'm just going to clip one lead on here just so I don't have to hold it, so I have a free hand. And we'll go on to neutral. Now I'm going to open the door and see if the short goes away. 0.1 ohm short. And the short went away. So what is that telling me? Do you know what that's telling? I know what the problem is. You remember from the diagram that I just had, where it showed you when the door is closed, you've got power going through, that switch needs to be open. But it's not. That switch is shorted. Because when I open the door, the primary switch opens. My short went away. So we know the switch is working. If it was the top switch that was bad, then it would short. It would still be beeping because the top switch was bad. We know what it is. It's the short switch. The short switch has failed. So let's remove it. So the three switches on the microwave, primary interlock is the top one. This one here, the bottom switch, is the, actually there's three switches. This one's got a middle switch and a bottom. On some microwaves they actually have these two together. But this one here has a separate one. But this is the short switch here, because this little one down here with the two blue wires on it, you'll see that they just go up to the timer. That's just to tell the system that the door is open to stop counting down. This is the switch here that's going to be bad. If I unplug one of the wires, then our short will have gone away. Right? Because I've removed the shorted switch. See, no more beeps. This switch is bad. And if I grab my meter and we just test the switch itself by putting the probe on the meter, this is a normally closed switch. So it's pushed down now. It should be open. But you see, the switch is bad. This is a normally open switch. This one's a normally closed switch. So if I just unplug this and take the switch out of here, which they come out pretty easy. They're just held in place by a couple little clips. Just pop the clip out, remove the switch, and go find a new switch for this. I probably have one. And I gotta get a fuse, of course, right? But this switch is, and of course it's welded because the switch itself, contacts bounced. Someone may have slammed the door a little too hard. That's usually what causes it. Sometimes you'll get, there's some grease and dirt building up on this switch here as well. So, but usually it's someone slamming the door. If I pop the switch apart, you'll find that the contacts themselves are welded shut. Let's do that. Let's open the switch up because inquiring minds want to see this thing spot welded together. And as you can see, the switch is welded shut. You can see the contacts there. That took 20 amps. These contacts are welded. They're welded good. Now this is a very important safety feature. You cannot defeat this switch. If I were to power this up now and put a fuse in it, it would work. But if there were something wrong, it would never blow the fuse. because the safety has been removed. So the secondary interlock switch is one of the most important parts that you've got on your microwave. That's your last line of defense in case the primary switch were to fail. Because what would happen if the primary switch failed, you could open the door and expose yourself to microwaves. It wouldn't be for very long though, however, because as soon as you open the door, the third switch would shut power off to or stop the timer, which would de-energize the relay. However, relays can fail. The relay, you see it right here. If the relay contacts were to stick on, for example, and you were to open the door and this switch was not present, the microwave would continue to run. The chances of that happening are slim, but they could happen. So let's go find a new switch and a new fuse and we'll get this thing up and running. Fortunately, whenever I scrap a microwave, I always keep the switches out of it. So I have a normally closed switch I can pop in here, and then all I gotta do is just get a new fuse for it. Just like that. So when the door closes, it closes the switch. Alright, now I can put the two contacts back on. It doesn't matter which one's which, because the job of this is just to provide a dead short in the event that the door fails to open, or the primary contact fails to open, should say, when the door opens. So now we should not have any short when I test. So when I open the door, we'll likely see the resistance of the light bulb, which we do. If I disconnect the light bulb, it should go back open. That's the resistance of the light bulb when we open the door. That's what we want to see. So now I just have to find a new 20 amp fuse. I knew I had fuses. 20 amp fast acting. Sitting in the drawer with my JB Weld. So it's got crap all over it. Alright, put the new fuse in. And then we can test this thing, make sure it works. Alright, I've got my current meter clamped on to the hot lead. I could use either one. I got the voltage probes plugged in to the input, and I'll plug in power. We haven't turned this thing on yet, obviously. And now it's going to measure the voltage, 120 volts. And if I... Oh, you know what I got to do? I got to plug the clock back in. I unplugged the wire from the clock, so obviously I have to plug that back in. Alright, let's try that again. Now the clock display lights up, and we're drawing 0.2 amp. Looks like it's taking a few watts right now. Open up the door, the light comes on, and we're drawing about 27 watts of power for the light bulb, 30 watts, which is about right. Okay, let's just set this thing for, I don't know how to work this thing. Let's see here, what do I do here? Stop. Okay, let's just put this thing on for a quick 30 seconds. I got a cup of water in there, and we'll turn it on. Drawing 14 amps. 1.6 kilowatts. If we look at the meter here, 115 volts. The voltage dropped a bit just from the line cord, the power cord. But it's working. I say I'm only heating it for 30 seconds, so this will just make the water a little bit warm. Oh yeah. Yeah, it's working. That was quite warm for 30 seconds. This is a powerful unit. So this unit is now repaired. I can remove my probes. I just did this to do the voltage calculation, right? I mean, this meter here, and you've seen me using this meter quite a bit lately, just because it's a very versatile meter. And yeah, I'm happy with it. But it'll give you your voltage reading and current consumption at the same time, which then of course will calculate out your wattage that you're using, your total wattage. So yeah, gets the job done. Rechargeable battery. I like it. I like it so far. Anyway, I'm going to throw this one back together and get this out of here as this one's fixed. And this is not mine. This belongs to a client that wanted it repaired. So it is now repaired with a new switch and a new fuse. Incidentally, I happen to have a bit for my little power driver that fits this. It's so silly using a little driver like this for these, but it gets the job done. Alright, thanks for watching. We'll catch you in the next one. If you've got a microwave that's blown a fuse, do check the switches, because that's usually what has gone wrong. And don't even think of operating it without the safety switches. They're there for a reason. Thanks for watching.